If you're just joining us, this is a bluShift Aerospace live stream of the first ever static fire test of our full-scale Modular Adaptable Rocket Engine for Vehicle Launch, or MAREVL, next generation hybrid rocket engine powered by a non-toxic, carbon-neutral, bio-derived solid fuel. The motor we will test this evening is about 10 times more powerful than the one which powered Stardust in flight in January of last year. And by the end of this year, we'll power Starless Rogue, our suborbital launch vehicle, to altitudes of 350 to 400 kilometers. Based on the latest report from the control room, we're expecting to test around 8:30 Eastern Time. So we've got a little while here. bluShift founder and CEO Sasha Derry is active in the comments section on YouTube, so feel free to send him a message directly over there. And we have an exciting little bit of content prepared to spend this time as we get ready for this historic test. Take you now to a view of MAREVL 2.0, nestled in the testing cell of Test Stand 2.0. And as you can see, we've got snow flurries here in Brunswick, Maine. Quite pleasant, us Mainers barely even notice. I mention it because we do have a little bit of snow and ice buildup on some of the cameras. And of course, safety being our top priority, no one will be wiping those off. So we may have just slightly fewer cameras than on previous streams. Thank you for your understanding. And again, it looks like we're on track for a test around 8:30 p.m. Eastern Standard, so just over 50 minutes from now. This is a bluShift Aerospace live stream of the first ever static fire test this engine. This is our MAREVL engine. It stands for Modular Adaptable Rocket Engine for Vehicle Launch. It's a hybrid rocket engine with a liquid oxidizer and a solid fuel. That solid fuel is non-toxic, carbon-neutral, and bio-derived. The motor that you see here is about 10 times more powerful than what flew in our prototype rocket, Stardust, in January of last year. Yeah, so seeing a couple questions about what happened last night. So this is our third consecutive night of trying to light this candle, as it were. The first night we had some issues with a stuck valve in the fire suppression system, and so did not ignite the main engine that evening. And then yesterday evening we had a little bit of trouble getting the igniter motor off to the side to start firing, and so we weren't able to ignite the main engine either. And this is one of the things that makes hybrid rockets so safe, is that the fuels tend to be incredibly stable, just by virtue of being solid and away from the oxidizer. So. Sorry about that. Thought we were getting an update, but it was just a comm check. All that is to say that our absolutely tireless team of engineers here at bluShift, they fixed the stuck valve, they fixed the igniter motor, and so there's always a little bit of uncertainty. This will be literally the first time ever that this engine has been operated. So we're on track for 8:30 p.m. And barring any further issues, this should be a historic moment for bluShift, Maine, and sustainable aerospace. DG Delta Golf on YouTube comments, if this goes tonight, he'll drop another 1K into our refunder campaign. Oh, no pressure indeed, Delta Golf. No pressure indeed. Engineers at Operation Control getting ready for their final checks. David Hayrikian, Nick Sandin, and you can see his hat there, Gerard Desjardins. So a little bit more about investing. bluShift is currently engaged in an equity crowdfunding raise over on WeFunder. Our goal is to raise $1.07 million. Money from this round of equity crowdfunding on WeFunder has already gone into hiring new team members. We've more than doubled the size of the engineering team. Folks with really impressive backgrounds, as well as construction of the test stand and the engine that you see before you, all funded by investors who may or may not have been accredited, who were able to get in the door for as little as $100, made this possible. Money from the ongoing current raise is going to cover additional or further testing throughout early 2022, so more opportunities to test this engine, dial it in, optimize it. Once we cross the $1 million threshold, we will actually unlock a tranche of non-dilutive funding from the Maine Technology Institute, $100,000 that will help kickstart not only those testing costs, but also the construction of 2 of our Starless rogue launch vehicles, as well as build out of a launch site. And I believe that Luke Sandin has joined us in the comments. Luke Sandin, Senior Mechanical Engineer here at bluShift. An Applied Thermal Sciences intern at NASA's Marshall Space Flight Center. And actually, during college, designed and constructed, played a part in the design and construction of the sounding rocket as part of Team Ursa at the University of Maine. So right now, the oxidizer is loaded into the system. We are just heating it up. And this takes a little while, so we expect to be ready to test around 8:30 p.m. Eastern Standard. If you're just tuning in, this is bluShift Aerospace live stream of the first ever static fire test of our full-scale MAREVL engine. It stands for Modular Adaptable Rocket Engine for Vehicle Launch. And it is powered by a solid, non-toxic, carbon-neutral, bio-derived fuel. This is a big step up for us. This is about 4 times the diameter, 10 times the thrust of our last engine. So this is a very exciting moment. And we are getting good luck wishes from across the states. Let's see who's from the farthest away. All right, so a question we get pretty often is, what exactly is a static fire test? So let me walk everybody through that, because that's a really good question. This is a little bit of a more obscure aspect to aerospace that not a lot of people know about or get to see. So we're excited to be sharing that with you. The short version, as I like to say, we won't be launching anything on purpose. The engine will remain in its cradle and generate all kinds of data. The big one, of course, is the amount of thrust that the engine generates, as well as vibration, or lateral thrust, which tends to be a little bit more variable. Various mass flow rates, temperatures, and the goal is to gather that data and use it to optimize the engine's operation. And we've done static fire tests on a number of different engines, and we'll be able to show you some of that in just a moment. We got a question here from Golden Hoodies. Do we hire people? And if so, what age do we hire at? Well, long story short, we accept applications pretty much rolling at our careers page. So you can just go to blushiftaerospace.com, and then under the Join Our Mission section, the bottom option is Careers. As a startup, we don't really have rounds of hiring on a regular basis. It's basically as needs arise. But that's how to apply. Fill out the contact form. Maybe follow it up with an email if you're so inclined. And then maybe we'll call you. All right, so in just a moment, I'm going to take you back to April of 2014. This is a few months before bluShift was officially incorporated. And our founder and CEO, Sasha Derry, was testing his rocket engine at his brother's farm, which I absolutely love, because every great sci-fi story starts on a farm, doesn't it? So that was one of the very first tests of a hybrid rocket engine powered by a non-toxic bio-derived fuel. And that was in right here in Maine. So it was a static fire test, right? You have the rocket engine. It's not going anywhere. You're just testing, you're observing how it operates to see if you can do a little better next time. And so that's basically what we're about. That's what we're going to do tonight. The engine will throttle up for just about 2 seconds, operate at partial power for another 5 seconds, and then cut off. And then over time, we're going to do progressively longer and more powerful tests as we optimize engine performance and then eventually get ready for flight. And if you're just joining us, this is a bluShift Aerospace live stream of the first ever static fire test of our full-scale Modular Adaptable Rocket Engine for Vehicle Launch, or MAREVL. This is version 2.0, which you see before you here. It's a next-generation hybrid rocket engine powered by the non-toxic, carbon-neutral, bio-derived solid fuel. And it's about 10 times more powerful than our last motor, which powered our prototype in flight. So this is a big step up. And in time, this engine will be sending payloads on suborbital flights of 350 to 400 kilometers. And then after a nominal flight, when it splashes down in the ocean, there won't be any harmful residues or anything like that from the fuel. All right, we're going to try something here. Stand by, getting an update from engineering. Well, they got me again. Thought we had an update, just a comm check. All nominal. So it does look like we are on track for that 8:30 test. In the meantime, we want to try something. So we're going to bring into the conversation here Lindsay Becker, one of our content creators here at bluShift. All right, Lindsay, talk to us. All right, we're experiencing some technical difficulties there. Hopefully that is the extent of our technical difficulties this evening. We'll try again in just a moment. Add her voice to the conversation. In the meantime, let me roll you a clip of a test of a 4-inch engine. So this is much later. This is 2016, 2017. The company had officially moved from Massachusetts back to Maine, back to Sasha's home state, thanks to a grant from the Maine Technology Institute. And so we built our first, dedicated static fire test stand. It was a vertical stand. So what you see right now is a rocket large enough that we have to test it horizontally. But back then, this was an engine of just 4 inches in diameter. We were able to test it vertically, which is, of course, more similar to flight conditions. All right. Happy to report we just had another go no go poll, and at this time, it does look like we are still on track for that 8:30 p.m. test. That would be in just over 23 minutes from now. One of the great things about our engine is it doesn't mind the cold at all. In fact, our electronics are more likely to complain before the engine does. Right on down to about, well, on the day that Stardust launched, it was as cold as 10 or 11 Fahrenheit. The rocket was just fine. So if you're just joining us, this is the bluShift Aerospace live stream of what will be the first ever static fire test of our full-scale Modular Adaptable Rocket Engine for Vehicle Launch, or MAREVL, a next-gen hybrid rocket powered by a non-toxic, carbon-neutral, bio-derived solid fuel. This motor is about 10 times more powerful than the one which powered Stardust in flight in January of last year. So a big step up for us. Currently on track, all nominal. Looks like we will be testing around 8:30 p.m., just over 20 minutes from now. So speaking of that motor, which powered Stardust in flight last year, we've been showing a couple of static fire tests of smaller engines from bluShift's past. And MAREVL 1.0 is what powered Stardust in flight, and that is the engine that we built and tested as part of a NASA SBIR grant from 2019 to 2020. So next we'll roll a clip, one of those tests. And this was one of the later tests, so a lot of the stability issues had been worked out, which are so common among hybrid rockets. And so just looking at the stable plume, before we even really looked over the data, we knew, okay, we're getting close to flight here. So this was a great moment, and if things look quite this good at 8:30 p.m., we will be thrilled, absolutely thrilled. But this is the end result. This is what we work towards on these static fire tests. Those were warmer times as we wrapped up the SBIR grant. The grass was green. So after that test, we built Stardust and had a series of static fire tests where the motor in its flight configuration was actually anchored to the purpose-built launch pad. And then it came time to fly. So we headed up to the Loring Commerce Center in Limestone, Maine. And here's what that looked like. This was Maine's first commercial rocket launch and the world's first commercial rocket launch powered by a bio-derived fuel, especially a non-toxic one. So this was a really great day for us and for aviation history. And it very much was not static. So if you're just joining us, just a moment here. Guess there's also some wind out there. But if you're just joining us, this is a bluShift Aerospace live stream of the first ever static fire test of our full-scale modular adaptable rocket engine for vehicle launch, or MAREVL, a next-generation hybrid rocket engine powered by a non-toxic, carbon-neutral, bio-derived solid fuel. And this motor is 10 times more powerful than what we just saw, MAREVL 1.0, launching Stardust into the air back in January of 2021. So as a static fire test, particularly the first test of a new engine, what's it all about, right? Well, the purpose is basically to achieve ignition and combustion, and to test the fully integrated MAREVL 2.0 and Test Stand 2.0. So it's command and control functions as well as its data gathering capacity. So what we'll see is the engine will throttle up gradually, more gradually than what will be normal eventually. It'll take about 2.5 seconds. It won't go all the way to full throttle. It'll be about 60%. It'll operate at that level for about 5 seconds, producing 50 to 60 kilonewtons of thrust, and then we'll have a rapid cutoff shortly after. So that's about 7.5 seconds of burn time. And over time, the tests will increase in duration and the thrust produced until we're getting 80 kilonewtons or better for about 85 seconds. So the historic first firing of MAREVL 2.0 is getting pretty close now. It does look like we're on track for that 8:30 test. So in just over 11 minutes, we're going to see this engine fire for the first time, powered by a non-toxic rocket fuel. bluShift founder and CEO Sasha Derry, live and lively in the YouTube comment section. So if you're watching on one of the other platforms on which we're streaming, head on over to YouTube. Send Sasha a question. And while you're at it, join our Discord server to meet not just Sasha, but the rest of our team and our amazing and fast-growing digital community over there. There's a quiz channel, folks already producing art. And it's just energizing to check in the middle of the day and hang out with folks on the server. Got a couple questions here. So we are indeed live. And it is about 8:21 local time, Eastern Standard. So we are about 9 minutes away from when we expect to test. Earlier in the stream, I apologized, but because of the snowstorm here, we're getting a little bit of icing on some of the cameras, so we don't have quite as many views to show tonight compared to nights prior. But so it goes. The most important thing is that it will not affect the performance of the rocket engine in the least. And quick update from the engineering team. It sounds like there's going to be a quick poll around 8:30, and the test will be shortly after. So just a few minutes past 8:30. You're getting mighty close to this historic moment for bluShift, Maine, and sustainable aerospace. First fire of a full-scale rocket engine that's ready to launch commercially. A single one suborbitally, and they can be assembled in a modular fashion to build a larger rocket that can reach orbit. So, again, just in case you joined recently, we'll run over what to expect for this test real quick. So we're going to gradually throttle up the MAREVL 2.0 over the course of about 2.5 seconds. And it'll operate at partial power for about 5 seconds. That should produce about 50 to 60 kilonewtons of force. And then we'll cut off and shut down the engine. The purpose is to achieve ignition and combustion for the first time on this brand new engine, as well as to test the control and data gathering capacity of Test Stand 2.0, a much larger test stand than what you saw in those earlier videos, although many of the blocks are the same. But a much more advanced sensor suite here to gather higher quality data and more of it as we prepare to fly one of these engines all the way to space. Not tonight. And it is 8:30 now. 8:30 now, engineers are conducting final roll. With final roll call complete, we're doing a quick scan of the exclusion zone. Just running through some procedure updates real quickly. Apologize for the absence. I'll update you, intern, shortly. All right, quick fire suppression test. Fire suppression is nominal. All systems go. Test imminent. Ignition sequence start. All right, we should have that igniter motor coming on soon. And there you have it. Here comes that fire suppression just to be safe. all accounts, a nominal test. Engineers just running a couple checks here.
Keeping that on. Yep. This is the system in state C, so that's us. We basically want to have all HOVs are obviously closed. All the ROVs are closed other than 3. Can you confirm?
Well, 10 and 11 are
10 and 11 are on.
Siren is still on.
Yeah, we got
want
visual
the siren
confirmation.
still on?
Let's keep the siren on until we're done with safety check. E-stops are all good, obviously. I hear siren. Yeah, siren's still on.
And very excited to speak with you now after the successful test. bluShift founder and CEO Sasha Derry has entered the booth.
Oh man, really exciting. I couldn't believe it. Oh, hey, this is great. It was fantastic. I went outside. It's snowing here, but you could see those flames so well, 0.6 miles away, and it was it was just how I think we were all envisioning it. You see the oxidizer ramp up. That was that sort of lazier flame, and then the solid burn for about 5 seconds there, and you could hear the hollering, the hooting
Oh, that was amazing.
from all sides. This was wonderful. My heart was beating 1,000 miles per hour. It was kind of hard to actually hold on to the binoculars while I was looking down downrange, but fantastic, beautiful. It was kind of fun to see it through the snow too.
I love that the smell is just rolling in now.
Is it? Okay, I can't smell it. I've got the mask on. Yeah. So the team has done such an incredible job. It was so, I don't think they constantly get less credit than they deserve for all the hard work and engineering they've done. Our team has been working days, nights, and weekends regularly till midnight plus, and it's finally come to full fruition. I've got to say that burn looked pretty stable too.
That did.
Every engine we've ever tested, from the very first one at my brother's farm back in 2014, ignition's the first problem, stability is the second problem, and then the third one is to get peak performance. We got ignition, and I got to say it was a short burn, but it looked pretty stable.
That was remarkably stable. I was expecting to hear a little bit of what they call it chuffing.
Yeah, or chugging.
I didn't hear that at all.
It looked solid. So we'll see. We'll analyze the data, but this is exciting. We have probably like 12 to 24 more tests to do, and we're ramping up to about 84 seconds of total burn time. Technically, we had enough fuel there to burn for 84 seconds, but the whole idea was this test is a test out ignition, the robustness of the whole system, things like seals, etc. And we'll be moving on to stable burn and high performance from here on out. So, and characterizing the engine. Very exciting. My heart's still beating like 1,000 miles per hour. So, yeah, thank you. Yeah.
Amazing work. Thank you everybody for being here to be a part of this with us.
And thank you especially to our team, because this would not be possible with all the folks on our team. This would just not be possible. They've put so much blood, sweat, and just incredibly hard work. And there's just a few of them
and
here.
they're
Let's bring
back
them up.
at work now.
Yeah, look at those
They
guys.
took just a moment and now they're back at it.
There's some of the guys, and there's guys out covering safety, a number of safety positions out in the field right now in the snow. I hope they're jumping up and down.
Absolutely.
Could you turn everything on first and then hit the e-stop?
Thank you, Sasha, for those words. As we that really was just amazing. I mean,
Here we go.
I think we all expected some sort of
Now you
anomaly.
can hit the e-stop.
Final review of the data, I'm sure, will show opportunities for improvement. But the fact that, visually, just listening to it, getting the smell of it, that was a good test. A good first test of a brand new rocket engine, 4 times the diameter, 10 times the thrust of what we've ever built or tested before. Still getting a fair amount of off-gassing here. Very thorough fire suppression. Just beautiful. And one other thing that I noticed was that it wasn't too loud. Here in the command trailer, we're about 0.6 miles away from the test site, and it just sounded like, well, we'll have decibel readings as part of the data too, but it really wasn't that much more pronounced than something like air traffic. It's quieter than anticipated. Someone mentioned there's still snow on the ground. And absolutely, yeah, you can see kind of a cone coming away from the engine. And that would be the region with the high flow of hot air. An atmosphere of celebration here, folks, jumping up and down. Well, we'll keep things running here just in case we get a preliminary report from the engineering team. And maybe answer a couple of questions, take a couple of comments. View from in the gas cloud here, a little bit closer up of MAREVL 2.0, having fired for the first time. With many successful ignitions to come. We got a question about replays from other cameras. Yes, that is very much on the drawing board. So we're going to get some high-resolution footage of the test, and hopefully get that out to YouTube tomorrow. eastern mast cam clearing up here a little bit. Blown clean by the wind. And on the right of the screen here, you can get a little bit of a clearer view of that cone extending outward from MAREVL 2.0 where the snow was removed. Just having looked at some of the 3D modeling, it appears to have been spot on. Thank you to everyone who's helping to share our story and bring in some audience members to watch, to participate. Things are really starting to settle down here. It's just a matter of time before it's another quiet, snowy night here in Maine. But things are a little bit different now. MAREVL 2.0 has demonstrated itself. And thanks to the hard work of our engineering team, the indefatigable effort of our engineering team, we have now taken our first step on this next leg of the journey. Onto space and then to orbit. Jason Fisher asks, are we going to attempt another static fire? Yes. Yes, somewhere between 12 and 24 of them is what we expect before we have an engine that is ready to fly. So there will be plenty of more opportunities to tune in and to see how we're doing. All right, so it looks like comms are getting a little bit quiet here, so I don't want to keep things going on too long. We will have that update to you just as soon as we can. So we'll push that out on the website, bluShiftAerospace.com, and our social channels as well. High quality video of this test to follow. That'll probably be tomorrow, but let's see. You can find us on social at Facebook, Instagram, LinkedIn, Twitter, and of course Discord. We'll share that link momentarily. You can also invest in bluShift at the address there on WeFunder. And for as little as $100, get in on the ground floor of a company that is re-envisioning aerospace, launching sustainable aerospace right here in Maine. That's about it for us here in Brunswick, Maine. On behalf of the whole bluShift team, again, thank you so much for being a part of this great moment. And we'll see you next time.